So after a short break, let's come back. We finished two examples about the definite integral to make use of the natural log derivative. So for those two parts, the natural exponential and the natural log function, their derivative, their indefinite integrals. Especially for their derivatives, to apply the chain rule, we discussed several examples last semester. That's why I didn't mention too many about this part. And for the integral, okay, the definite integral or indefinite integral, that is the topic we studied this semester. So I give two examples about the natural log and how to combine with the substitution rule. Okay, we can get more practice in the homework for this part. All right, let's start the next section, the inverse trigonometric functions. So we will look at the inverse function of sine first. So let's review the sine function, okay? So y equals sine x, okay? Y equals sine x, and we know for the sine x, the domain is all the real numbers, right? Let me show you the sine functions, okay? Let me show you the sine functions. So from 0, this is pi, this is 2 pi, here is minus pi, right? So sine function is periodic with the period 2 pi, right? Period 2 pi. And the range for this function is exponential growth, 6.1 exponential growth. We will skip that part. Okay, very good question. Yeah, 6.5. We will skip that section. It's the application of the exponential function in some biology or population models. We will skip that part. So let me continue here. Y equals sine x, as I said. The first domain is all the real numbers. The range is -1 to 1. And if you use the horizontal line test to check, of course, it's not 1 to 1, right? When we want to mention the inverse of sine function, we need to check whether it is 1 to 1. Of course, it's not a 1 to 1, right? It's not a 1 to 1. Then how can we check this function? Its inverse. So if we limit the domain, from minus pi half to pi half, if we only take this part of the function from minus pi half to pi half, using the horizontal line test to check, you will notice that this part, okay, when I define my domain is between, of course, it can equal to minus pi half. So from minus pi half to pi half, then you use the horizontal line test to check. Now it becomes 1 to 1, right? It becomes 1 to 1. And here the domain is minus pi half to pi half. How about the range? Of course, the range is the same from -1 to 1, right? -1 to 1. So use the horizontal line test to check. It only intersects the curve once, right? Between -1 and 1. If you have horizontal line outside greater than 1 or less than -1, no intersection. So when we talk about the inverse, okay, we can limit the domain from minus pi half to pi half. but it's not always working for 1 pi. You can check that the length of the interval is pi, but if you limit your domain from 0 to pi, it's not a one-to-one function, right? It's not a one-to-one function. Let me just write, this is y equals sine x. So if you limit your function from 0 to pi using the horizontal line test to check, it's still not one-to-one. So even though the length of the interval is pi, but should be minus pi half to pi half, or it can be pi half to 3 pi over 2, right? It can be 3 pi over 2, but it's not 0 from 0 to pi, because this one is not one-to-one. Then we cannot talk about its inverse, right? Now let's check its inverse, okay? Let's check its inverse for the sine. So if we limit, okay, we limit this function sine, then that is from minus, here is minus 1, okay? The function value is minus 1. Here is 1. Here is 1 from minus pi half and pi half. It's increasing, and we can talk about its inverse. How can we write its inverse? You can write minus 1, right? You can minus 1 as a superscript, and it's also called arcsine, okay? Arcsine. So we can write in this way, okay? My function y equals sine x, fx is sine x, and the inverse is arcsine, okay? Arcsine. Then from this one, what is the domain for sine x? The domain for the sine x should be minus pi half to pi half. It should equal to the two endpoint. Only equal to the endpoint, we can take the function value minus 1 and 1. And of course, the range should be minus 1 to 1, and it's closed, right? Closed. So the domain of this sine becomes the range of the arcsine. So the range for arcsine is minus pi half to pi half. And the range for sine becomes the domain, which is minus 1 to 1. That is the graph we get for the sine on the right part, okay? On the right part. So comparing the domain and the range for f and its inverse, right? And its inverse. So this is the graph for the arcsine, okay? Arcsine. So the domain is minus 1 to 1, and from minus pi half to pi half, the range. So that is arcsine, okay? Arcsine. And the derivative of arcsine. We are going to derive this derivative a little bit, okay? A little bit. Why we I believe some of you have already memorized those arcsine, cosine, their derivatives. Now let's derive for this one, okay? Now let's derive for this one, why it gives this fraction. So first, we let y equals sine x. We will write the inverse function directly, okay? We will write the inverse function directly. So let y is this inverse. Then we need to work out dy over dx actually, right? Dy over dx. And here, what is the domain? What is the domain for my x? I can rewrite in this way, okay? Let me rewrite this way first. So that means x equals sine y, right? If we let y is sine inverse x, then we can express x as sine y. Now what is what is my y? My y is between minus pi half, right? For sine function, the domain is minus pi half to pi half. And what is the range for sine? Minus 1 and 1, right? So my x is between minus 1 and 1. Now, for this function, x equals sine y, we are going to differentiate this function with respect to x on both sides to apply the implicit differentiation. Okay, so differentiate on both sides. Differentiate the function. Differentiate the function on both sides with respect to x. With respect to x. And we can write it for short w dot r dot t to represent with respect to. Okay, so when we take derivative of x, of course is 1, right? It's 1. When we take derivative of sine y, then it's cosine y, right? It's cosine y. Let me move a little bit, give more space. So take derivative for the left side is 1, and then the right side should be cosine y. Since y is the function of x, okay? Y is the function of x, 牵路 times dy over dx, okay? Times dy over dx. So we can work out dy over dx is 1 over cosine y, right? 1 over cosine y. But we are going to express the y using x, okay? Because finally the function should be an expression about x. Now let's recall one identity, okay? One identity here. So let me explain this one a little bit. Sine square y plus cosine square y equals to 1 for any y, right? For any y. And what is my y? My y is between minus pi half and pi half, right? Y is the range for the inverse function, or it's the domain for the sine function. So this is true for any y, right? For any y. My y especially is on the minus pi half, from minus pi half to pi half. So this is true. And especially here, y is between minus pi half and pi half. So let me move here a little bit. And I will show you the graph. Since y is between minus pi half and pi half, how about cosine y? So cosine y will be greater than 0, okay? Cosine y is non-negative. How can we check that? Show the cosine curve. Show the cosine curve. That is cosine y. You can take it as x, okay? It doesn't matter. You can take it as cosine x. Just the letter y means an independent variable, okay? An independent variable. So here is minus pi half. Here is pi half. So when you have the independent variable between minus pi half and pi half, then the cosine is non-negative, right? Is non-negative. Everyone is clear? Let me show you a different color. So when the independent variable, I'm not going to call y or x. When the independent variable, you can call it t, okay? T. When my t is between minus pi half and pi half. So cosine t should be greater than 0, right? When my t is between minus pi half and pi half. Everyone is clear? So I use t to avoid the confusion. So of course here sine square plus cosine square equals 1. Then this cosine should be non-negative. It's true for the t. This y is just a special symbol we use in this example, right? So how can we express cosine y? Since cosine y is non-negative, so according to this identity, my cosine y will be 1 minus sine square y. And when I take the square root, it should be plus minus, but I only take the positive root. I will drop the minus 1 because this cosine is non-negative when I have my variable between, when I have my independent variable between minus pi half and pi half. So that is an expression, okay? That is an expression. And here we can write it. That is 1 over square root 1 minus sine y. What is my sine y at the very beginning? Sine y is x, right? So that is 1 over under the root 1 minus x squared. But be careful, okay? Be careful. At the very beginning, we said x is between minus 1 and 1 can equal to minus 1 and 1. But here, to make the denominator defined, 1 minus x squared cannot equal to 0. So we will drop the equal sign. Of course, here x should be between minus 1 and 1 without the equal sign. That's why we will mention here. Okay, we will mention here. According to the arcsine, the domain is minus 1 and 1. No problem, equal, right? This is the domain for the arcsine function. Okay, domain for arcsine function, right? This is the domain for arcsine, or we just write sine inverse. But why we drop minus 1 and 1? Because if you write this one in the denominator, it should be defined. It cannot be 0, right? That's why we limit it. It's minus 1 to 1. And so we just explain a little bit. The derivative of arcsine gives 1 over the root, okay, 1 over the root. And again, in another way, we can write it the indefinite integral 1 over the root dx. So that will be arcsine x plus constant c, right? Once we know the derivative, we can express the antiderivative using the indefinite integral, right? And we know this x should be defined. Also, this x should be defined between minus 1 and 1. Why? Because under the root, 1 minus x squared should be positive here, right? Under the root, 1 minus x squared should be positive. It cannot equal to 0, right? Because it's a denominator. So when you solve, so that means x squared less than 1. X squared less than 1. Of course, you solve x should be minus 1 and 1. When you write the fraction in this way under the root, that means your x is between minus 1 and 1. Okay, so the indefinite integral is arcsine and plus constant c. Okay, so that is the arcsine. Okay, arcsine. We checked its graph, domain, and range, and its antiderivative. Its derivative as well as the indefinite integral. Right? Which function gives the arcsine as its antiderivative? So this function's antiderivative is arcsine, right? Now let's start the cosine function, okay? Let's start the cosine function in the same way, okay? In the same way. So if we look at the cosine function, and we know that it's defined for all the real numbers. If we check the graph, Of course, it's also not a it's not a one-to-one function, right? It's not a one-to-one function. Let me just draw the graph of the cosine, okay, of the cosine. So in this way, this is minus pi to pi, okay, minus pi to pi. And this is 1, right? The range is minus 1 to 1. So here is minus 1. And if you use the horizontal line test to check, of course, it's not 1 to 1. Then we cannot talk about its inverse. Then we limit the domain for this function. So you can choose this part, okay? You can choose this part. Or in our textbook, they choose this part. They choose the from 0 to pi, okay? We follow this one. So you can choose minus pi to 0 or 0 to pi, okay? 0 to pi. So it is 1 to 1 from when we limit the domain from 0 to pi, right? Or you can choose minus pi to 0, right? Minus pi to 0. But you cannot choose it from minus pi half to 3 pi over 2. For example, you cannot choose from minus pi half to pi half, okay? Minus pi half to pi half. This is also the length is pi, but it's not, okay? It's not because it's not a one-to-one function, right? It's not a one-to-one function. So the domain for the cosine should be 0 to pi, and the range should be minus 1 to 1. No problem, right? No problem. Now let's check its inverse. Let's check its inverse. So inverse cosine function from 0 to pi minus 1 to 1. So we limited. The domain is from 0 to pi. Let me draw the same table, okay? The same table again. Fx equals cosine x. Then its inverse, we just called arc cosine, okay? Arc cosine. Then the domain for the cosine will be 0 to pi, right? 0 to pi. So 0 to pi, from 0 to pi, that becomes the range. That becomes the range for the inverse, okay? For the inverse. And then the range for this one is minus 1 to 1. That becomes the domain for its inverse, right? So it's easy to check the domain and the range for the inverse if you draw the table like this one, okay? So arc cosine, the domain should be minus 1 and 1. Range will be 0 to pi, right? Will be 0 to pi. And what is the derivative of the arc cosine? Minus, okay? We have the extra minus. Extra minus, it's the same fraction, 1 over under the root 1 minus x squared. Of course, it's still the same. The x should be between minus 1 and 1, not equal. So in the same way, minus, for the indefinite integral, minus this one equals arc cosine x plus the constant c, okay, according to the derivative, okay, according to the derivative. And how can we understand the graph, okay? How can we understand the graph for sine and its inverse, cosine and its inverse? Let me just show you, okay? So the derivative and the indefinite integral are pretty easy, okay? This one we just have the extra minus, okay? Extra minus here. Now let me show you the sine and sine inverse. Okay, so here two color. Okay, two color. Y equals sine x, and use the green. Y equals sine inverse. Let me show those two functions in the same graph. Okay, in the same graph. So we will take from minus pi half to pi half, right? Sorry, that should be the red color. Let me start the coordinate again. So I will use the red color to represent the sine function. And we defined the sine function from minus pi half to pi half, right? Pi half. So here is minus pi half to pi half. And then let me use the green one to denote the sine inverse. What is sine inverse? Sine inverse is from minus 1 to 1, right? Minus 1 to 1, and from minus, the range will be from minus pi half to pi half, right? Let me just show, okay? Let me just show. Wait a moment. So it looks like this one, okay? It looks like this one. From minus 1 to 1. And here is minus pi half to positive pi half. That is the inverse, okay? Sine function, this is the y value is minus 1 to 1, right? And then from minus pi half to pi half. What is the relation between the green and the red color, those two curves? Actually, they are symmetric, okay? They are symmetric about the straight line, okay? They are symmetric about the straight line. Y equals x. They were not passing through this point. It's not that precise. Should be this one, okay? Should be this one. Y equals x. So what does this mean? What does this mean? So for any function, actually, fx for the graph, okay, fx and its inverse, fx and its inverse, their function curve, their function curves. We already checked the domain and range, but we haven't checked what is the relation between their function curves. Okay, their function curve actually are symmetric about the straight line. Y equals x. About the y equals x. the straight line. This one is not very straightforward. Okay, this one is not very straightforward, but we can check it for the tangent x later. Okay, for the tangent function later, it will be more obvious. Okay, it will be more obvious to check that. So it's the same. Actually, it's the same for the cosine. Okay, for the cosine and arc cosine. So I will finish a little earlier today, and I will answer some questions for those who submit their homework through the emails.